Hello everyone, welcome back to PMAC1114. So today is the first video for application, and this is the first chapter, the first section we have for application of trigonometry. The application of trigonometry is related to the triangle, or especially the right triangle. In this video, I also introduce some terminology, some term that help you to understand and comprehend the word problem, because application is a word problem. If you don't understand the word vocabulary, then of course you cannot visualize, you cannot imagine the scenario, and you cannot draw the picture, and that's why you cannot solve the problem. Okay, so on the first example, we'll go straight to the example. This first example would be the simple standard one right triangle. Then on the second part, we're going to talk about some the angle of elevation and depression. So that's a new terms over there. Then we talk about bearings. Okay, so let's get started. So we're gonna go ahead and jump to the example right away. So in section 5.4, talk about application. Okay, in right triangle. Okay. Sorry, I have pretty bad allergy today. My nose is in my throat, so be patient with me. Okay, so the first example, we're gonna have something like this. So I ask you to solve. When I ask you to solve triangle, or right triangle, I mean they ask you to find on the other side an angle in the right triangle. Okay, if triangle ABC, if A equal 29.43 centimeter and C to 53.58 centimeter. Now, when you read the problem, you see this, they didn't tell you which side is A, which one is C. So this is a right triangle, so you know right away the longest side should be hypotenuse. And we don't know which one is the longest, because over here we have only two sides. We don't have the angle. We don't have a third side, so we don't know. So the problem must give you more information, okay, to determine which one is the longest one. So usually they must give you the picture. If they don't give you the picture, they must give you something. So in this example, I give you the picture. It's a right triangle. And over here, this one is A, and this one is C. Most of the time, the C is hypotenuse, guy, but it doesn't mean that, okay? It doesn't mean that. This is B, and most of the time, the A1 is the longer leg, and the B is the shorter leg. But you see that it doesn't mean always like that, right? You see over here, I put the longer leg is the B, and the shorter leg is A, so it doesn't matter. But we know for sure because B is the longer leg and it's smaller than the hypotenuse. So when you solve for the B, when you find B, the value must be smaller than this. If the value of B is bigger than this, it's bigger than the C, then something is not right. Okay, if it's bigger than this, something is not right. Okay, so what we're gonna do, very easy, guys. We're gonna use sine, cosine. We know last time we know sine is opposite hypotenuse, cosine adjacent to hypotenuse, tangent opposite of adjacent, and cotangent is the reciprocal of the tangent. So we're gonna use that because they ask you to solve right triangle. So we need to find all of this. We need to find angle over here. I'm gonna call this angle alpha, and over here angle beta. So I can use sine alpha. Sine alpha over here, the opposite would be this, opposite over hypotenuse, which is 53.58. Okay, we're gonna go ahead and put it into the calculator. Then in order to find alpha, I already give you the first the example in the previous video, in order to find alpha, you're gonna find inverse of this. Okay, so we're gonna find inverse of that. Okay, so let's let's go ahead and put it into the calculator. Okay, so you can put inverse the TI-84, whatever you have, of the 29 43. Okay, over 53 150 58. Okay, and make sure the unit you have will be in degree, because we never taught anything about radian except for the conversion between radian and degree, but we're gonna go deeper into that later on in terms of radian. So we the answer is 33.317 degree. Okay, if you set it in radian, it will be in radian, but the value won't be like that. So that's alpha. And we can find beta easily, right? We know the sum is 180, so we know we'll take the 180 minus 90 and minus the 33.317. Okay. And what I give you? 56.69 degree. Okay, so we have alpha, we have beta, we have A and C, so we can find B easily. Use Pythagorean theorem, so B squared equal to C squared minus A squared, so it will be 53.58 squared minus 29.43 squared. Okay, just go ahead and put it in. Square 29.43 square. Okay, so I go ahead and take square root of that. So I have 2004.69, and you take square root of that, give you, well, so the B will be 44.77 centimeter. And of course, don't forget the unit. If they don't give you a unit, then you don't have to put a unit, but on the test or whatever it is you do on homework, make sure you have to include unit. Okay. So the triangle I have over here is a very simple triangle, right triangle. Well, if you have a chance later on, I believe it's during the last semester, we're going to talk about solve triangle, and they require you to solve the number of triangle given a certain information, because given a certain information, we can find at least 2 right triangle or more than that, sometimes 3, sometimes 1, or sometimes we don't have any triangle. But I don't know that in this textbook they're talking about that. But if you have a certain trigonometry class, they talk about have to solve right triangle or solve the triangle in detail, not just solve right triangle, but solve triangle in detail. I believe that you're gonna learn that after you learn log sine or log cosine. But in this moment, it's very simple like this. Okay. And sometimes they don't give you C, they give you A, they give you the angle, sometimes they give you the beta, sometimes they give you alpha, but you're gonna use the same logic. Okay, sometimes you gotta use cosine, sometimes you gotta use tangent, the opposite of adjacent, but kind of the same concept. Now, in the next video, oh, I'm sorry, in the next example, I'm going to put it as a first problem here. I'm going to solve two special triangle here. The special right triangle created by two special angle position we call the angle of elevation. Angle of elevation. and depression. So what is angle of elevation and what is angle of depression? elevate, right? So we look like we want to elevate something. So just imagine you have you have um, initial sign like this, and at the beginning, initial sign and terminal sign overlapping each other, and then suddenly the terminal sign, initial sign, terminal sign, the terminal sign rotated and it's rotated over the upward like this, counterclockwise. This is called angle of elevation because it's open like that. So this is the x-axis. Okay, so they open it like this. Elevation, uh, counterclockwise, and for the depression, we also have the x-axis go like this, and the the terminal side this way, but instead of open like that, it's open downward clockwise. Here you go like this, and this is called depression. Yep, that's all. That's all. That's all you need to know, the vocabulary, because most of the program probably they give you the picture. If they give you the picture, it's easy. But they don't give you the picture. They just say, okay, angle of that elevation, angle of depression, or elevated or depressed by a certain degree, then you know that. That's how you're gonna draw the picture. For example, I give you something like this. Example number 2. Uh, at a point A, 123 feet from the base of the flagpole, the angle of elevation to the top of the flagpole is 26 degrees. The angle of elevation to the top of the flagpole is 26 degrees for the minute. Find the height of the pole. All right, so first of all, we need to change the unit because it have the minute over here. So, so remember how to change it? Anyone remember how to change from uh, degree to DMS to DD? Anyone remember? Huh? You remember that we had to do division or we had to do multiplication? Anyone? Probably forgot. Okay, so this is how you set up, guys. 36 degree at so minute. Okay. 1 hour is 60 minutes. So you're gonna put 40 over 60. Okay, so we're gonna end up with 36 degree. Okay, so for will be 2/3. 2/3, right? So 2/3. So it's about 76. 26. 2/3 is 2 divided by 3. So we end up with 26 2667 degree. Okay. Okay. So now we're gonna go ahead and draw the picture. Point A over here. The flagpole right here. Okay, so there's a flagpole. Okay. And over here, he say what? 120 feet from the base of the floor. So this is the base. So from here to here, 123 feet. And elevation to the top. So this is the top flagpole. This is a flag. Okay. Okay. US. Okay. Some style here. Have some stripe over here. Okay. And to the top of the flagpole. And this is the ground elevation. Okay, 26.667 degree. Okay, find the height. Oh, very easy. Just find this, right? Find this. So this is the opposite. Is adjacent. So we're gonna use tangent. So tangent of 26.667. Tangent opposite. Opposite. I'm gonna call this B and C. Opposite to BC over adjacent. Adjacent is this 123. So BC is the height of the flagpole. So BC. Then you're gonna have 123 multiplied by tangent 26.667 degree. Gotta put into the calculator, guys. Okay, go ahead and take tangent of that. Make sure you're gonna put the degree symbol. That's the degree symbol. Then you multiply by 1, 2, 3. So you have 61.773. What is unit? Because it's the height, so it must be feet. Okay, so the flagpole is about 61.773 feet. Around 61.0. Pretty good. Pretty good amount. Okay. Easy, right? Not bad. Example 3. Now, in example 3, we will deal with diagonal regression. From the top of of a 210 clip, David observed a lighthouse that is 430 feet up the shore of the shore. Find the angle of depression from the top of the cliff to the base of the lighthouse. Okay, I'm going to give you 1 minute to try to visualize the scenario, and let's see if you can draw the picture. Okay, go ahead. 1 minute. I'll be back. Okay. How's the picture? Okay. Uh, so we have the cliff and we have the lighthouse. Of course, we assume that is the sea level is not above the ground, so it's on the same level. So we have the cliff over here. Here the cliff. Okay, and here the cliff, and this is the seashore. Okay, and there's an ocean over here, so they have a lighthouse right here. Okay, so that's a lighthouse. Okay, so the guy is standing up here. The guy is standing on the cliff. Okay, and the cliff over here 210. So this is the ground, the shore, is ocean, something like that. And also the lighthouse that is off the shore, so it's off the shore. So from here to here is 430 feet. Okay. So you look at this from this position. I will call this position is A. You look at this and you see that it creates the depression because it's along the x-axis like that. So we look at this one. So look at that. Or you can draw up here, or you can draw it out here. I'm going to draw it out here because it's going to go ahead and create a triangle. So, okay. Okay. So look at that now. You look at that. But where's the angle of depression? Depression according to the, with respect to the x-axis. So this is the x-axis. Okay. So right here. There you go. So they're asking you for this angle alpha. How do we do that? Okay, I don't know if you guys do remember this. The concept we have in the geometry. As I told you, the first video I said the geometry and trigonometry is related to each other. So you see that is the x-axis over here and the ground parallel to each other. So this is interior alternating angle. So the angle alpha over here is the same as angle alpha right here. Interior alternating angle because it's parallel to each other, transversal line. So we can use tangent. Okay. Opposite over adjacent, tangent alpha. Opposite over adjacent. Then alpha will be inverse tangent. Opposite over adjacent. Okay. Now what I give you? And you're gonna put inverse tangent. Okay. 10 divided by 430. Give you angle alpha is 26.03 degree. Okay, see that? See, very easy, right? Super easy. Of course, you're gonna do more of this application, right? Yeah, they're gonna put you in a different scenario, and yeah, they require you to draw the picture, so you need to be expose yourself to different problems. That's why I continue to recommend you to buy the textbook, trigonometry textbook. Get a cheap one. Get a cheap one. If you can afford a brand new one, sometimes the brand new one, but the old version is also cheap. Get that. If you don't like want to use one because it's kind of dirty, contagious. So buy the old version but brand new. Let's help on eBay, guys. Just get something to so that you can practice. Believe me, ebook will work. I don't know how it's work for you guys. Probably work for some of you, but to me, it's not working. When I was in grad school, for my degree, I always bought textbook. Okay, now the next terminology I want to introduce is bearing. Okay, and bearing is just the one of the special position of the angle. That's all. And there are two methods for bearing. Okay, two methods of expressing bearing. The first one, I'm going to call it A. The first one is based on the north direction. So it's based on the y positive axis. Okay, it's a y positive y axis, the north direction. Okay, and it measure. It's always measure clockwise. So it's always go like this. It always go like this. Okay, but the reference direction is the north. Okay, and it's always measure clockwise. Okay, who care about the negative or positive at this moment? Because this application we never have a negative value. Okay, so all the angle over here is always positive, even though that it respect to the north direction and it go clockwise. Remember last time we said last time clockwise we had to do negative, right? But it's not in this case because we're doing application. Okay, and the second bearing position is measure with respect to north and south line. So respect to both north and south, not just north. So north, okay, and south. So north and south considered as the reference axis. Okay, so it could be either positive, y, both positive and negative y-axis, not just positive. And and this the angle we measure is to show the angle we measure is to show how it goes, how the angle opening to the west or to the east with respect to the north south line. Okay, it could be respect to the north, respect to the south, and it goes it either go west or east, but north or south is your reference line. Example, I can say like this. I can say that um, I can say that this is this is west, this is east, west, east. So this is east. I can say this is angle over here. Okay, and I can put this is north. Okay, north of east. All right, I can say north alpha degree is. Okay, north alpha degree is. Or I can say this is also it, but I use south. I can say this one south beta degree is. Okay, so beta degree is. Or I could go this way too. Or I can say okay, I can say not alpha beta gamma not gamma degree west. Okay, or let's see if we can use different color over here. Or I can say south. So I'm going to call this sigma south, sigma degree west. There you go. So you see that there are several there are 4 different ways to call it bearing direction. Okay, so 4 different position for the bearing measuring. Okay, so it depends on the problem. Sometimes they use northeast, sometimes northwest, sometimes southwest, sometimes southeast. Oh, I don't know. Is anyone can see the red color? Maybe you okay with the blue, right? Not red, right? Because I'm afraid that some of you couldn't see in red. Sigma west, sigma. There you go. I just want to make sure everybody can see the video. Okay, now let's start with the example. Example number 4. Okay, a ship leaves port and sail on bearing of north 47 degree east. Okay. For 3.5 hour. It then turn and sail on a bearing on a bearing of south 43 degree east for 4 hours. If the shipwreck is 22 knots, find the distance that the ship is from the port. So you see over here, they don't give you the picture. They don't give you the picture. I mean, you gotta draw the picture. Okay, you draw the picture wrong, everything wrong. So you don't want to draw it wrong. You need to understand what's going on over here. A ship leaves port and sail on a bearing north of east. So you know that for direction it's north, south, east, west. North of east, 47 degree. So right over here, okay, this is north. Okay, 47. So they go like this. Okay. For 3.5 round, it then turn and sail on the bearing south up. So this south. Okay, it's not south. South up east is over here. So south east to go like this. Uh-oh. This is 43, right? Because this is east. Okay. It's not south. And over here 4 hour. So 4 hour, then 3 hour. Okay. 3.5 hour, 4 hour. Well, you can make it a little bit longer if you want to. It's not a big problem. Okay. Find the distance that the ship from the port. So the ship right here, port right here. We'll call it P. Oh, they ask you to find this. Find the point D distance right from here to here. I'm gonna call this A. I'm gonna call it B. Okay. So how we do that? Now, so you see that so far we're dealing with the right triangle. So all the problem we must be right triangle because if it's not right triangle, cannot do. But when we draw that, it's not right triangle. Oh, why? Actually, because it's not in scale. But we must know that it must be a right triangle somewhere. But where's the right angle? Right here we have 43, 43, 47, 90. How do you know 90? Because there's a parallel. Say 47 right here, guys. Alternating exterior, interior angle. 47, 47, 47 plus 43. 90. So it's 90. Right triangle. You see that my picture is not scale, but it's almost, right? So, right triangle. Uh, this is 3.5 to get here. It is 4 hours to get here. And we want to find the distance from P to B. In order to find the distance from P to P, we need to find the distance from P to A and from A to B. How we do that? Okay. Think a little bit. How we do this? We need to figure out that we need to find the goal. The goal is to find PA and AB. We need to find all of this. How you do that? Now we need to figure out why they give us the 3.5 hours. 3.5 per hour. That's the velocity, right? And we know that according to what we already know, the D equal RT. D equal RT. Did it tell you the T? 3.5. Oh, that's a T 3.5. Okay. And the ship rate is 22. So we can find the distance. So we can find PA. D equal RT. R is this 22. T 3.5. And AB the R times 4. Okay. What to give you? We'll give you 88. Okay, 88. What's the distance over here? Because the 22 knot, the knot is actually unit is miles. So we're gonna have mile. Okay. It should be nautical miles, not just because we are dealing with the ship, so nautical mile, not mile. But I'm gonna put mile. Okay, and 22. 5. 77. Nautical miles. So from here I can get PB square will be 77 square minus 88 square. Plus, I'm sorry. Then take square root. So PB will be equal to square root of 13,673. Have 116. 16.93 mile. Wow, I don't think I put into the calculator wrong. Please check for me you have a calculator. 88 square plus 77 square. Take square root of that. Yeah, this should be it. Okay, so that's the answer. 0 to 5. Okay, how about this? Radar station A and B on east-west line. 3.7 kilometer apart. Station A detect plane at sea on a bearing of 61 degree. Period. Station B detect simultaneously the same plane on a bearing of 331 degree. Find distance from A to C. Okay, I give you 1 minute to think and draw the picture. Go ahead, girl. I'll be back. Okay, you guys got the picture? Okay, so of course both of the radar must be on the ground. So both of the radar must be on the ground. So radar A here and radar B here. Okay, and then over here they said 3.7 apart. So the C is the plane bearing 61 degree. So this is y-axis, north one, north direction, 61 degree. So look, let's see over here. Just imagine. So something like that. See right here. So this one, 61 degree. We remember this the first method of bearing, right? We're gonna draw the picture based on the north direction, and the second one is bearing 331 degree. Oh, okay, 331 clockwise, right? Clockwise. Must be clockwise. So 331. So almost 360. Not. So 331 is almost a whole revolution. Only 30 left. So it's gonna be like this. So only 30 left. See that my picture is not scale, guys. So there's this 331 right here. So this one is only 30 because 30 plus 331 is that 3, hold on, 360 minus 331, 29, I'm sorry, it's only 29 because 29 plus 331 give you 360, the whole revolution, whole circle. So where's the right triangle? Oh, must be right triangle somewhere. Just imagine we have the right triangle right here. Why I can say that? Because this interior alternated 61 degree, interior alternated is 29 degree, 29 plus 61, 90. So this 90. Is it parallel, everything parallel, interior alternating. Okay, so what we need to find is in between A and C. Okay. So this between A. So this is where A and C, this one. So we can get this. We get the angle here because it's 90. 90 minus 29. 61. So it's 61 degree. Okay, so we can use sine is opposite over hypotenuse. Sine 61 degree opposite AC. That's what we want to find. Hypotenuse 3.7. So we can get AC will be 3.7 times sine 61 degree, which is okay, sine 61 okay degree times 3.7, about 3.236 unit kilometer. Okay, easier, not bad. But I told you, some problem. You have to be exposed to different type of problem. I cannot do all of them because there could be a lot, and video probably take 10 hours if you do all the example problem. So your job is to get use the ebook or get a physical textbook, any textbook, do more problem on the bearing. Okay, you get used to it, then you'll be able to draw the picture and solve the problem. Okay, so I'm gonna start the video over here. It's more than an hour. Actually, most time we have face to face that I'll let you guys practice, but because we don't have face to face course, so it is online one. So I'm gonna stop right here, and if you have any question, please let me know. I'll see you next time.